Good morning, students, and it's good to see you on us almost last day of our unit. We're going to start with, let me get rid of that. We are going to start with our do now. We have an interesting question today about loving others. We'll get to that. It's National Pets Day. Our objective today is to review for our polynomial unit test. And our central question, of course, is are you ready to show what you know about polynomials and factoring? For your assignment, I would like you to complete the do now, 2 pages, the exit ticket. Distance learners, make sure you turn your work in on Teams. If you're in person, I will come around and see your work. For homework, I want you to listen carefully. You have in your packet a pair, check, and verify activity. It has 2 sets of 12 problems, 12 on the left and 12 on the right. I only want you to do the problems on the left tonight. Tomorrow we'll do some more review, and you can do the problems on the right tomorrow night. But for tonight, just those problems on the left. And the important thing to note, you know what's coming are quadratics, so get really strong with this factoring. And for your exit ticket, I really want you to just identify one area of this unit that you need to improve and make a plan to practice that skill today and tonight. So we'll get back to our do now in a minute. I just wanted to show you these are our pages for today, the study guide pages. We have a little mindful art and a mindful game activity. Those are mixed up, scrambled pet names. And we have last night's homework solutions. So let's get back to our do now. Some people say pets give us unconditional love. They love us when we are at our best or not behaving well. Is it possible to love somebody else unconditionally? Are some people easier to love than others? And it's an interesting question. And I'd like you to think about that and just not yes or no, but tell us why there. So let's get started with our review. And we'll start with a darker color today. So we're going to first write polynomials in standard form. When we write them in standard form, we use ABC order, and then we have descending order of exponents, largest to smallest. So this would be 3a to the fourth plus 2a to the third plus a squared minus 7a minus 4. And number 2 would be 2x to the third, remember ABC order, minus x squared y minus 3xy squared plus 8y to the third. That's it. So now in our second group, we're asked to classify each polynomial by degree and number of terms. So that's the exponents and how many terms are in there. With the exponent on the variable is 1, we have a linear expression, and with 2 terms, it is a binomial. Number 4, with just a number, we call that a constant. It's a number without a variable, and that is 1 term. That's a monomial. Number 5, we have an exponent of 2. That makes this a quadratic. And with 3 terms, it is a trinomial. And number 4, that has 1, 2, 3, 4, 5 terms. So that's a polynomial with an highest degree exponent of 4, which makes that a quartic polynomial. Okay, now the third topic we're going to look at is simplifying polynomials. So we're going to simplify them and write all of our answers in standard form. Remember, that means ABC order with decreasing exponents. So 2x squared plus 3x plus 2 minus the quantity of x squared minus 4x minus 1. 2x minus x squared would be x squared. So that takes care of that. 3x minus 4x minus a negative 4x. Well, that means we add the 4x, so that would be positive 7x. And 2 minus a negative 1 means we add the 1, that would be 3. Number 8, we're multiplying. So 2a to the third. So we have to multiply the 2a to the third times every term in those parentheses. And then when we're done that, then we're going to add the 3a to the fourth minus a to the fifth. So first we will have 10a to the fifth minus 14a to the fourth plus, so this is the distribution here. We still have that 3a to the fourth minus a to the fifth, and we add combined like terms is simply what we're doing. We will have 9a to the fifth, 10a to the fifth minus 1, 9a to the fifth minus 11a to the fourth. It's negative 14 plus 3, and that's our final answer. Okay, number 9. We're going to multiply 5c squared d times all three terms. That would be 9 times 5 is 45. C to the fourth, d to the third. 5 times negative 4 is negative 20. C to the fifth, d to the second power. And then 5 times negative 2 is negative 10, and we have c to the second d. And this next problem, first we need to multiply negative 4y through to the binomial terms, and then we need to multiply negative 2y through, and then we'll have some subtraction we have to do. So we'll start out, we have negative 20y squared plus 44. Negative times a negative is a positive, plus 44y minus 6y squared minus 20y. And let's see what terms we can combine. So negative 20 minus 6, both are y squared. That's negative 26y squared. And then positive 44y minus 20y is a positive 24y. Okay, number 11. We're going to use FOIL for this. We have two binomials, so x times x squared minus 3x inner minus 4x. Negative 1 times negative 3 is a positive 3. We can combine the inside two terms to give us to give us, forgot to put my 4 there, 4x squared, negative 3x minus 4x minus 7x plus 3. Okay, the way to handle number 5, okay, we obviously have a difference of squares here, is to write it out. So we have 5y minus 1, 5y minus 1. So 5y times 5y is 25y squared. 5y times negative 1 is negative 5y. And the inside, negative 1 times negative 5 times positive 5y is negative 5y. Negative 1 times negative 1 is positive 1. We combine the two negative 5y's for 25y squared minus 10y plus 1. Okay, number 13. Again, we're multiplying, and really it's just a little. It's still FOIL, but it's just a little bit more complex. So 2x times x is 2x squared. 2x times negative 3y is negative 6xy. 5y times x is positive 5y. And 5y times negative 3y is negative 15y squared. And we can let's see, what can we combine? I forgot my x here. Let me just clean that up a little bit. That inside, this is the inside term. It should be 5xy. And we can combine the middle. So 2x squared minus 6 plus 5 is minus 1xy, and that 1 will be invisible, minus 15y squared. Okay, number 14. Remember multiplication and addition before, multiplication and division before addition and subtraction. So we're going to do this FOIL first, and then we will subtract the negative 2. So 4x times x is 4x squared. X times negative 2 is negative 2x. 4x times 4 is positive 16x. 4 times negative 2 is minus 8. And then we have to subtract negative 2x squared. Okay, let's combine like terms. 4x squared minus 2x squared is 2x squared. Negative 2x plus 16x is positive 14x. And then we have our negative 8 at the end. And that's our final answer. And number 15, we're dividing. So when we divide the denominator by each term in the numerator. Okay, so negative 8x to the fifth divided by 4x to the third. Remember, we subtract exponents when we divide. So negative 8 divided by 4 is negative 2, and x to the fifth minus x to the third, or divided by x to the third, is 5 minus 3, which is x squared. 28, positive 28 divided by positive 4 is positive 7, and x to the fourth divided by x to the 3 is just x, and negative 4x to the third divided by positive 4x to the third is negative 1, and that's our final answer. And number 16, same kind of problem, so let's do the coefficients, and then we do the exponents. 27 divided by 3 is 9. C to the 4 divided by c squared is c squared. D to the 7th divided by d to the 3rd is d to the 4th. Plus 15 divided by 3 is 5. C to the 3rd divided by c squared is c. D to the 5th divided by d to the 3rd is d to the 2nd. Okay, let's move on to the second page. We have some geometric applications. And asked first to write an expression to represent the area of the rectangle in the simplest form. So area equals length times width. So we need to multiply this length times the width. So it would be x squared minus x plus 3 times 4x plus 1. So let's just distribute through everything. We're going to end up with, we have 3 terms here and 2 terms here. So we're going to end up with 3 times 2, 6 terms. So x squared times 4x, that's 4x to the third. Negative x squared times 1 is x squared. And now negative x times 4x squared is negative 4x squared. Negative x times 1 is negative x. 3 times 4x is 12x. And 3 times 1 is 3. So there's our 6 terms. So let's combine 4x to the third. We don't have any other 4x to the third terms, so we can write that. X squared minus 4x squared is negative 3x squared. Negative x plus 12x is 11x. And we have our constant of 3, and that is our final answer. Now, in number 18, we're asked to write an expression to represent the area of the shaded region in the simplest form. So, we need to find the area of the entire thing. So length times width, x plus 2 times x. So we'll start there. We have x times x plus 2. And we're going to subtract 7 times 3. So minus 7 times 3. And that'll give us the shaded area, the only part that we're interested in. So x times x squared, plus 2x minus 21, and that's our work is done there. Now we're moving on to factoring the polynomials. And we're asked to factor each polynomial completely. So first I look at the constants, and then I look at the variables. So I have a 54, an 18, and a 27. That means I can factor out a 9. And then I can factor out the lowest common variable. So that would be x, 1x to the first power, just x to the first power. And I can also factor out a y to the first power. So this is my lowest exponent x and my lowest exponent y. So that would give me 6x squared minus 2xy plus 3y. And that's our final answer. Number 20. We want to factor out 9x squared minus 49y squared. That's the difference of squares. This is a perfect square minus a perfect square. So the square root of 9 is 3. The square root of x squared is x. So 3x plus the square root of 49 is 7. The square root of y squared is y. So 3x plus 7y, 3x minus 7y, and our work is done. So we don't have a perfect square in number 21 because of this exponent here. But we can factor out 16y to the fourth, which would leave us with 4 minus y squared. Now, 4 minus y squared is a perfect square. 4 minus y squared is 2 plus y, 2 minus y. And then we still have that 16y to the fourth power. And what can we factor out of number 22? We can factor an n. We always look for a greatest common factor first. That would give us n squared minus 5n minus 50. And we need two numbers that add to negative 5 and multiply to negative 50. That means we need a positive and a negative number, and certainly negative 10 and a positive 5 would work for us. Negative 10 plus 5 equals negative 5. Negative 10 plus 5 equals 50. So that would be n times the quantity of n minus 10, n plus 5, and that's our final answer. Number 23. This is a 4-term polynomial, so let's factor by grouping. So first we'll factor out a 4x squared from the first group, which would leave us with x plus 3. So we want to be left with x plus 3 here. That's our goal. So what am I going to have to factor out? Well, I'm going to have to factor out a negative 25. So that leaves a final answer of, well, I don't think it's going to be final yet, 4x squared minus 25 times the quantity of x plus 3. However, 4x squared minus 25 is a difference of squares. So that would be square root of 4 is 2, square root of x squared is x, and square root of 25 is 25. So that would be 2x plus 5, 2x minus 5 times x plus 3. And number 24. First, we always factor a greatest common factor out. So I see we can take out a 3, and that's it. We cannot take out a variable. So 3 factored out leaves us k squared minus 19k plus 60. And we need two numbers that add to negative 19 and multiply to 60. And 60 is 15 times 4. And if the 15 and the 4 were both negative, they would add to negative 19 and they would multiply to positive 60. So that means 3k minus 15, k minus 4 is our final answer. Now we have a couple of slip and slides here. So 2 slip and slide problems. So let's get those done. We're going to move slip 4 next to 14 and multiply, which will give us m squared minus m minus 56. I need two numbers that multiply to 56, negative 56, and add to negative 1. So that would be negative 8 and positive 7. So I will write m minus 8, m plus 7. Now I need to take that leading coefficient of 4 and divide both these factors by 4, which gives me m minus 2 times m plus 7 over 4. We're not going to reduce that. Now we do the slide. We take that 4 and we're going to move it up in front of m. And our final answer will be m minus 2 for m plus 7. And number 26, always factor out what you can first. We can factor out a 2. So that would be 2r squared, leaving 4r squared. Let me just write that a little more neatly for you. So factoring out a 2 leaves us with 4r squared plus 8r minus 5. And I'm going to slip and slide for this. So 4 minus 5. So 2r squared plus 8r, 4 times minus 5, negative 20. I need two numbers that add to positive 8 and multiply to negative 20. So it's going to be a positive and a negative number. And I can get there by 10 and 2 if the 10 is positive and the 2 is negative. So 2r plus 10 r minus 2. And now I need to divide by my leading coefficient, not the 8, but the 4, okay? You don't want to multiply by the 8, you go back to the 4. So we're going to divide by 4. And when I simplify that, I have 2 times r plus, I'm going to reduce that to 5 over 2, and r minus 2 divided by 4 is going to be 1/2. Now here's where I slide. 2 comes up in front of the r in both cases, which leaves us with a final answer of 2 times the quantity of 2r plus 5, 2r minus 1. And that's our final answer. Just a couple more problems. If the area of a rectangle can be represented by x squared minus 5x minus 14, what two expressions could represent the dimensions of the rectangle? This is kind of a quirky question. They're just asking you to factor this into two expressions. So factor this into two expressions. So I need two numbers that add to negative 5 and multiply to negative 14. So we need a negative and a positive, and that would be negative 7, positive 2 to get to that negative 5. So that would be x minus 7, x plus 2. Which is a little quirky, I think, that question. Okay, so now we're just going to do some polynomial division. So first we factor the trinomial. So we need two numbers that add to negative 14 and multiply to 48. So that would be two negative numbers, negative 6, negative 8. So that would be x minus 6, x minus 8. And we're dividing by x minus 6. And we cancel the common factors, and our answer is x minus 8. Now we have p squared minus 9 divided by p minus 3. This is a difference of squares, so we're going to factor that out as p plus 3, p minus 3 divided by p minus 3. And I'll cancel the common factors, and the answer is p plus 3. And then finally, our last one, we have a quartic. So we're going to factor by, not a quartic, excuse me, a four-term polynomial. It's still quadratic, but it's a four-term polynomial. So I'm just working with the numerator for now. I'll save the denominator for later. So a squared b plus a squared c, I can factor out a squared, which leaves me with b plus c. And then negative 5b minus 5c, I can factor out a negative 5, which will leave me again with b plus c. Remember, a negative divided by a negative is a positive. So I can rewrite that as a squared minus 5 times b plus c, and I'm dividing that by b plus c. And I will cancel out the common factors, and I'm left with a squared minus 5, and that is a final answer. So polynomials and factoring is pretty meaty unit. There's a lot there. Please do those 12 problems I assigned for homework. Identify what area you're still weak in, that you need extra help in, and ask for that help. And keep practicing. Keep working as hard as you've been working. Been so proud of you guys lately. So keep working hard, because with practice, you'll be great.